All right, so back in the kitchen here. Before we get deep into lesson 36, I got a couple things I want you to add to your notes. Now, I know I'm doing this later in the evening, and that's why there's 5 dots on the light there, but you're going to have to be able to see around those, and hopefully they won't mess things up too terribly much as you see. All right, lesson 96. You need this for your notes. This equation, x equals negative b over 2a. You will use that formula a bunch tonight. It's a brand new formula, and it's not that tough. It's just like any other formula. You just simply plug in the numbers that you're given, and you'll be fine. This formula is to find the axis of symmetry in a parabola. Everything we're doing tonight is dealing with parabolas. Symmetry is a term that you will get a ton of next year in geometry. Symmetry just means whatever is on one side, the other side is exactly the same. It's like taking a mirror and setting it down right in the middle, and whatever's on the left, the right is exactly the same place. So any line that exists like that, that's not too good a picture of one, but any line that would list whether it's a parabola or whether it's just a line, if there's something that cuts it right in half, that is a line of symmetry. And we're going to be talking about the zero function. Also, the zero function is the y-intercept, and that's something else that will show up in our notes tonight. Plus, I want you to write this down because you're going to be really happy about this. I know I am. Okay, a website called GeoGebra. Spelled that way, GeoGebra. That way, I'll tell you about it later, but I'll tell you now, I'm so excited. It is an online graphing calculator. So if you don't happen to have a graphing calculator at home, this works as good as any graphing calculator. And the video that I'm going to send you later, the lady is going to use this website with the problems that you have been doing, and she will walk you through each step of how to use that graphing calculator that is at this this website. So that's going to make life tons easier for you. You'll be able to actually do some graphing tonight, and you'll have this stuff right there with that online graphing calculator. All right, so let's jump to it here. I'm going to take this out. Hopefully you've got all that in your notes, because today is probably the best example of anything we've had all year of how algebra is simply learning to follow steps. Okay, it's called the algorithm. And if you can learn the algorithm, you'll be fine. But today, oh my goodness, there are a ton of steps. Okay, so here it is. Let's go to the very first one, and this is on page 638. I'm going to do the examples that are in the book, and then the video that I'm going to send you with this will show you examples that are not in the book, but actually are. They're right here on the side, but they come directly from this lesson. All right, so we have y equals x squared plus 4x plus 5. Now, we've done a whole bunch of different things with this, but what we are going to do today is actually graph it. If you have graph paper, great. If you don't, you'll get by. It's not the end of the world right there. Okay, so we're going to do this a little bit differently. We're going to say step 1. And step 1 is actually using this formula right here, x, that we showed you before. X equals negative b. Now remember, I told you the negative sign can technically go anywhere. So sometimes they say negative b if they drop the negative sign down there. Doesn't matter. All right, so now we are going to take the information that we have from this equation and plug it into this equation. And let's see how well you remember where we find these different things. Okay, b is actually this right here, if you remember. So we get 4 over, and a, if you can remember, would normally go right here, but since there isn't anything, that means that would be 1. So we have to put 2 times 1. Well, I never said algebra was going to be tough math, but here we get equals, again, a negative, because I put my negative in there. Okay, negative 4 over 2, which is equal to, and I know this is a cardinal sin, huh? Too many negatives on one, too many equal signs on one line. Never, never, but we do it here. Okay, so the axis of symmetry is going to be negative 2. Now, that's wonderful, but it doesn't tell us much. So now we have to go to step 2. And step 2 is to find the vertex. Now we should remember how to find the vertex. I'm not going to write the equation again. They have it in the book. It is the exact same equation as this one right here. But once again, they're going to plug in what they have into this equation, because now we know that x is equal to negative 2. So we plug that in right up there. And we get y is equal to negative 2 squared plus 4 times negative 2 plus 5 is going to equal 1, because we plugged in, for the x, we plugged in this negative 2. Now to solve this, not all that tough, we get negative 2 times negative 2, which is positive 4. 4 times negative 2 is going to be negative 8 plus 5 is going to equal, should come out to 1, right? Oh, see, I cheated. I already had the answer in there. Okay. Because 4 plus 5 is 9, minus 8 is 1. So pretend you didn't see that, okay? But there it is. There's where the answer comes out. Now, where is the vertex? Well, the vertex is negative 2, 1. So when we go to graph this thing, we know this parabola, we go to negative 2, 1, and we'll have exactly where the vertex goes. All right, everybody got this? Because we're not done. We still have more steps to do, but as long as these steps make sense to you, then you should be in good shape. Now we need to go to step 3, and I'm going to leave that equation up there in the top. And the other thing we should leave up there is the vertex is negative 2, 1. All right, so now we go to the third step, and we need to find the y-intercept. Okay? In order to do that, if we look at this equation, it's not that tough to do, because if you remember going back a couple of lessons ago, the y-intercept is just simply right there. So the y-intercept in this equation, which is equal to 5. All right? Piece of cake. That was, by the way, step 3. Now we have to go to step 4, which is find one point of symmetry. Okay, so before we get into that, we have that same equation up there. If you were going to graph this thing, which we are, we have a little bit that we know already. Okay, I'm just going to kind of go like this, like this. We know that the vertex is at -2, 1. So we put it somewhere right about here. Okay? And we know that the y-intercept is going to be, if I go like this, 1, 2, 3, 4, 5, and I go 1, 2, 3, 4, 5, that the y-intercept is going to be right there. Now remember, we are making a parabola. So, and this is our vertex. So, one thing about symmetry is everything on this side is going to be the exact same as this side. So I can right now tell you that if I go 1, 2 over here, I'm going to go 1, 2 over here and up to 5. And of course, this is not exactly to scale, but this one, the symmetric equivalent of that one is over here. And we're going to get ready to make that. All right. Now, they tell you in some places to do 2 of these. In this particular example, they only do 1. This is step, well, let's see, that's step 4. And they picked a number, okay? And then they tried to make their life easy, so they picked the number 1. And they plugged it into the equation there of y equals, and they made x into 1. So they ended up with y equals 1 squared plus 4 times 1 plus 5. And that will equal to, well, let's figure it out. 1 squared is 1. 1 times 4 is 4. 1 plus 4 is 5, and 5 plus 5 is 10. Okay, so if we chose 1, you know, this is kind of like doing this. Remember this? We went x and y, and we picked these. In this case, we picked x to be 1. If x is 1, then y has got to be 10. Okay, so now I come back over here. I do the positive 1. And I'm going to go, let's see, 1, 2, 3, 4, 5. 10 would probably be up around here. The symmetric of that, we go 1 more out this way and up to this. And it looks like this. And now we can go step 5 is just simply to graph it. Well, that ain't hard because all that's really doing here to graph it is play dot to dot right there. Okay, and you'll hear this lady say that, you know, it's not a V. Remember, it's more of it's a U shape right there. But there it is. Okay, now I'm going to cheat. I'm going to tell you about this right now. You guys talked about this before, but ask yourself, what are the zeros on this parabola? Hopefully you were smart enough to remember there are no zeros on this particular parabola because it does not cross the x-axis at all. Okay? So that is example number 1 that is in that book. Lots of steps, none of them all that difficult, just lots of steps. And of course, just like anything else, if you mess one step up, the rest of the thing is completely messed up. All right, so let's go to example number 2. And this is on page 630, these glasses don't work, 39. All right. Here we go. Example number 2. And here's the equation they give us. We're going to do pretty much the exact same thing. Y equals 3x squared plus 18x plus 13. Okay? Now, here we go. Step 1. Find the line of symmetry, which means, again, we've got to whip out our handy-dandy formula. X equals negative b over 2a. Okay, we plug in what we know. We get x equals, b in this case is 18. And a in this case is 3. I hope everybody sees where I'm getting those from. The 18 came from there. The 3 came from there. And out of this, we get, oh, and do not forget your negative sign. Okay, those disappearing negative signs will get you every time. Okay, 2 times 3 is 6. 18 divided by 6 is 3, so our answer is negative 3. Do not forget that negative sign there. Okay, so now we have our axis of symmetry. We move on to, that was step 1. We move on to step 2. Okay, step 2, we got to find the vertex. Okay, and in step 2, we have that same equation. And what we're going to do is plug in our numbers. This is actually, if you really remember, it's A, B, and C right here. Okay, so now we're going to plug this in. We're going to get x is equal to 3 times, because here's where we're getting the negative 3 from. 3 times negative 3 squared, because this is taking the place of x right there, because we said x is equal to negative 3, so we plugged it in there, we plugged it in there, right? Good. Now we have 18 times negative 3, because again, that x became this negative 3 right here, and then we add 13, and if you do all this properly, you get negative 3 squared is 9. 9 times 3 is 18. 18 times negative 3, that's going to be a minus there, huh? Oh, golly, what's that going to come out to there? They kind of skipped that whole step. 3 times 18, that's going to be 54. And then plus 13. Okay, 13 and 18, that gives me 31. And minus that, you should end up with negative 14 right there if you do all that properly. That's right. Okay, you get all that proper, it should come out to negative 14. All right, so now what is our vertex? Our vertex is negative 3, negative 14. That looks like it's going to be a big graph right there, huh? Okay. All right. Okay, step 3. Step 3, we are going to find the y-intercept, which we know is letter C. Okay, the y-intercept is always is letter C. So in this case, it's going to be 13. Okay. Now we can come back and take the same equation and plug in. We're going to substitute. Actually, this is step 4 now. Now, this is, again, we picked a number. Okay, we didn't find it anywhere. We said, gee, what number is going to make my life easy? And in this case, they chose, on the example 2 here, they chose negative 1. Okay, they said x is equal to negative 1. So wherever x is, they plugged in a negative 1. And so they got 3 times negative 1 squared, okay, plus 18 times negative 1 plus 13, okay, and if we do that right, we should get positive 1, we should get 3, we should get minus 18 plus 13. 13 and 3 should give us 16. And if we do this right, and we did, we get -2 out of that. Okay? Just like it says there. So the point that's on the curve. Now, here's where we're going to have to do some graphing again. Okay, let me make a nice graph here as best I can. But if we do this and we do this, okay, we know that the vertex is at -3, -14. Now, look in your book. This is really interesting. Look in your book on page 639. I want you to notice, look very carefully at the x-axis and look very carefully at the y-axis. They do something real interesting here. If you notice that the scale is not the same. The distance between the numbers on the x-axis is only 1 for each of the lines there. But when you look on the y-axis, they're 5. Did everybody notice that? It's 5 each one. That's because they did that because you got this big old -14 here. So anyways, they went with -3 down here, -14. Okay, they were able to do it that way. That's why it fits on here. They also figured out that it will cross, or they came up here with this negative, what did we come up with here? We had -1, -2, right? Because we said we chose number 1, -1, so we end up with a crossing point of -1, -2. So that's going to be back 1, down a couple, right to here. If we check our symmetry, we should get one right over here as well. Okay, and where does it cross the x-axis? Well, we did that right here. That's going to be all the way up here at 13, and there should be one on the other side. Look just like it. Okay, you guys know the old story. Your parents always tell you, I brought you in this world, I take you out, make another one look just like you. Okay, there's the perfect example of that. Okay, and then the last part is the easy part. Step 4 is playing dot to dot. Again, it's a circle, it's not a V, and it should look like that. You can see it on the bottom of page 639. Again, notice that the scale of the X and the Y are not the same. You can get away with that when you make the book. All right, last one that I'm going to show you is going to be example number 3. And here's what they do with example number 3. It's not a big deal, but it is a little bit different. Don't want it to throw you. They don't give you a middle term. Okay, so the equation on this one is 5x, y equals 5x squared plus 4. Notice that we're used to that middle term of just being an x, and there isn't one here. All right, no big deal. Okay, we start again. Step 1. We use our formula. X equals negative b over 2a. We plug in what we have. Now in this case, b, not there. There is no b. You notice? Now b. No big deal. We put in a 0 because there's none there. Okay, the a is there. That's 5, so we get 2 times 5. Now, once again, and don't forget our negative in here. Okay, but it doesn't really matter because anything under 5. Now we can do this. If the 0 is in the denominator, no such animal. But right here, we can do it. Bottom line is this whole thing equals nothing. You did all that hard work, and what do you have to show for it? Nothing. All right. Step 2. Got to find that vertex. Okay, once again, we're going to go back in. We're going to plug the number that we just found. Okay, so we get y equals, okay, 5. Well, I got that up there. So it's 5 times 0 squared plus 4. Not real tough because 0 squared is 0. 0 times 5 is 0. Plus 4 is going to give us 4. Okay, so the vertex is 0, 4, right there. Okay, even though there was no middle term there. That wasn't real tough. All right, step 3. Okay, find the y-intercept. Well, that's easy. Again, it's just this time every time so far they've given us a y-intercept. If there was nothing there, then the y-intercept would be what? It would be 0. Okay, but there is, so the y-intercept is going to be y-intercept is going to be 4. All right, and then finally we go on to step 4. Well, we're going to pick a number. If we wanted to, we could actually start graphing right now. Okay, if I actually made a graph right now, I could do this. Okay, the vertex is at 0 elevator, 4th floor. Okay, the y-intercept, well, guess what? We already knew that. That y-intercept, we can find it that way, but it really didn't tell us anything we didn't already know, that the y-intercept was there. So now it becomes important that we pick some numbers. Got the x and the y. Okay, just following what they did in the book here, they once again decided to choose -1 for x and then plugged it into this equation. So we get y is equal to 5 times -1 squared plus 4, okay? And that's going to be -1 times -1 is +1, times 5 is 5, plus 4 is equal to 9. So plug that in right there. And we go -1, 9. Okay, now the good thing then, doing symmetric, this is as easy symmetric as you can be, because it's right on there. So you go +1, 9. I know that's right. Okay, because it's going to be symmetric right there. Did they do another one? No, they didn't. But from right here, you should be able to still draw your parabola. Okay, looking like this. Okay. All right. So there's examples 1, 2, and 3. Now, example number 4 says finding the zeros of a quadratic function. Now, this one right here is actually pretty simple. Once again, are there any zeros? In this case, yeah, no, there's no zeros. Okay? But on number 4, you see it says use a graphing calculator to make your life easy. Now, again, on the video that I'm going to send to you, that lady does a really nice job of showing you that website that I gave to you, okay? And there's a graphing calculator there, and she walks you through every step way better than I can. So just follow the stuff that she has right there. If any of you have any questions, let me know that if it's not working for you, let me know. All right, while I have you here, before you take off, let me give you the homework, okay, which is going to be, what color should I use, huh? Should we use green? Let's use green for homework. Homework, page 642. You are going to use A through G. By the way, D, E, and F say use the calculator. If you have any problems, let me know, but it's still pretty doggone simple. You can tell what the, if you had to, you could just graph it and find a lot of those. But if you don't have to and you can use the graphing calculator, fun, okay? It'll come in handy later. Again, let me know if you have any issues. And then the rest of this is just simply 1 through 9. A little shorter than last night, okay? But none of this should be all that terribly difficult. All right? Have fun with this, and you get to, I always said, you never get to use calculators. Now you get to use a calculator. Should be all there for you. All right, I will see you tomorrow. Have fun.